Hi, this is Paul, City Sailing. We're done for doing all that learning. Let's see if it's still in there and how much we know. We're going to go for a day skipper quiz. Great thing to do before a general assessment and quite an entertaining thing to do. I would like to say thank you for doing the course. Also, thank you for Chris Murdoch for putting this together. So here we go. Day skipper quiz. Question 1. Let's go. On Admiralty charts, from what levels are the heights of lights measured, heights of bridges measured, depths measured? So the heights of lights and heights of bridges will be from a different level. So you ready? Go. So heights of lights are measured from mean high water springs. The heights of bridges are measured from the highest astronomical tide. And depths are measured from chart datum. Where is compass variation found on charts? So you're looking to find your compass variation. Where would you look? Okay, let's have a look. So you go to the nearest compass rose. Has to be the nearest compass rose because they differ from compass rose to compass rose. And it's written at the top of the compass rose. So compass variation is shown on the compass rose. In this case, it's 7 degrees, 25 minutes west, 2005, decreasing 8 minutes east. We've shown you on previous city sailing tutorials on how to calculate it, the value of variation for your year. If the height of tide is 3.5 meters, what is the depth in these three positions? So A is a depth of 2.4 meters, B is a depth of 17.2 meters, and C is a drying height of 2.5 meters. Let's have a look. So A, height of tide is 3.5 meters, charted depth 2.4, add them together, 5.9. B, height of tide 3.5, charted depth 17.2, add them together, height is 20.7. C, height of tide 3.5 minus the drying height because it sticks up, so it's minus 2.5, which equals 1 meter. Where can information be found about corrections for paper charts? Are you ready? So on the bottom left-hand corner of your chart, it tells you when the chart is updated to, the year and the number of that correction. On the websites of the Hydrographic Office, Trinity House and Harbour Authorities, it will give you information, and there's usually a search option for that chart. It's found in Weekly Notice to Mariners. Some magazines will publish it. The Weekly Notice to Mariners comes out each week, or on the Hydrographic Office website. Buoyage and pilotage. You're heading south when you sight the following buoy ahead of you. Which side do you leave the buoy, port or starboard? So it's quite easy to learn this, but we learn it on a north-up situation. So if you go further on and you do exams with the MCA or an examiner, they love reorientating the chart. So now we're heading south and we see this. So we need to know what it is and what direction do we avoid it. So we're heading south, we sight the following buoy ahead of you. Which side? It's a west cardinal, so we pass it to the west. So there we are heading south, we pass it on our port hand side. Which types of buoy shows the lights with these characteristics? VQ brackets 3 6S, ISO 8S, QG, Q bracket 6 plus LFL 20S. Let's have a look. VQ3 6S, white light, 3 quick flashes or very quick flashes every 6 seconds is an east cardinal mark. ISO, white light, equal periods of light and dark, 4 seconds on, 4 seconds off to make up the 8 seconds. It's a safe water mark or a fairway mark. QG, it's a green light flashing quickly, quick green, starboard, lateral mark. Q6 plus long flash every 20 seconds. It's a white light flashing 6 plus 1 long. It's a south cardinal mark. What type of buoy is this and what does it show? Let's have a look. It's a special mark. So special buoys are not navigation marks. They're used for racing marks, data collection buoys, marking outfall pipes, recreation zones, or for specific areas. What type of buoy is this and what are its light characteristics? Let's have a look. It's an emergency danger mark, and it shows a blue and yellow alternating flashing light. Using a back bearing, if the bearing increased, would you turn to port or starboard to stay on course? So the bearing's increased, so to get back on course, you turn to port. You create a clearing bearing on a lighthouse to miss some rocks. Are you in safe water if the bearing increases or decreases? You're in safe water if the bearing increases. Now let's have a look at weather. You have a 4-day weather facts, but weather doesn't seem to be as per your forecast. So name 4 sources of weather information you could use to check the forecast on a small craft at sea. So what can we use? Let's have a look. Observation. Your barometer, which measures the air pressure. If it's going up or down quickly, it means it's going to be windy. Clouds. Mobile phone. You can use a short messaging service or the internet. BBC shipping forecast on Radio 4. Local radio forecast, which changes from wherever you are. VHF radio broadcast from the Coast Guard. And they'll be once every 4 hours, and you'll find the times of that in the almanac. Navtex if you've got it. You can call the Coast Guard, but only in emergency. Television, maybe not. Internet. If we're close enough to get GPRS signal, we can get a weather forecast off our mobile phone. Suggest 4 factors that influence how rough the sea will be. We've done a whole video tutorial on this called Waves under the City Sailing Tutorials. Let's have a look. Strength of the wind, direction of the tide. So wind and tide together will be smoother, wind against tide will be rougher. The fetch, how far the waves have travelled. The depth of water, so shallow water makes the waves break. How long has the wind been blowing in the same direction? Is it increasing or decreasing? A skipper of a planing motor vessel is planning a passage west along the south coast of England. The weather forecast is southwest force 3. He decides to go against the tide. Why? And the clue is he's a planing motor vessel, so it's a fast motor vessel. Why do you think? The clue's in the tide. Let's have a look. The sea will be smoothest when the tide and wind are together, allowing the skipper of the motor cruiser to make the boat speed to optimise its fuel consumption. So wind and tide together, it's flatter. So even though you're going against the tide, it'll be easier for the boat because it's going on flatter water, and it'll be able to go faster and it'll be able to plane. Wind against tide, it will just bounce from wave to wave and it'll be extremely uncomfortable. The wind is forecast northerly, force 5. What sea state would you expect close inshore? Have a think about that. South coast of England and a northerly wind. Wind comes from, tide goes to. So the wind is blowing off the land. It's an offshore wind. So close inshore, it'll be sheltered, flat, little waves. What is the direction of the wind in A, B and C? This is a typical day skipper question. So we've got low pressure to the right, high pressure to the left. Which way does it go round? So this is northern hemisphere. Which way does it go round a low northern hemisphere? And how much does it blow in from the isobars? So have a look at that. Let's have a look. So A, southwest. B, northwest. C, south. While on a passage, the visibility begins to deteriorate. List 4 actions you would take as you enter fog. So you enter fog, what are you going to do? Establish your position, so find out where you are if you don't already know. If you've got a radar, make sure it's on and working. If you've got electrical power on your motorboat, the radar should be on all the time anyway. Put up a radar reflector. That's if you don't have a permanent one. Have your white flare ready. Put on your navigation lights. Put extra lookouts out. Put on life jackets if you don't already have life jackets on. Navigate at a safe speed. Wake up the crew, especially in the front cabin, because you don't want, if you hit anything, you don't want people to be stuck in the boat. Make the appropriate fog signal for the vessel you're on. Consider the use of the engine. The disadvantage of an engine is that you can't hear other vessels' engines and you can't hear other fog signals as well as if you're sailing slowly. Consider a change in destination, what's safer. Make for shallow water if it's safe. Big ships will not hit you if you're in shallow water, it's physically impossible. Consider anchoring in a safe location. Have the dinghy or the life raft ready. Use all your instruments to the full. And use all your senses as well. So you'll be able to smell a ship. Okay, that's most of them. And there's quite a lot to do. Electronics. Why is it recommended for boats making passages over 30 miles offshore to carry an EPIRB? So look. So an EPIRB, emergency position indicating radio beacon. When activated, it sends a distress signal on 406 MHz and the position of the vessel using the GPS via satellite to the rescue services. A vessel over 30 miles offshore may be outside VHF range, so the EPIRB is a good alternative worldwide. So an EPIRB will be able to locate your position within minutes of you being in trouble. To me, it's one of those absolutely essentials that you need when you go to sea. Hopefully you'll never use it, but absolutely essential. Which of the following will your portable GPS give you? Speed through the water, speed over the ground, both. Let's have a look. Speed over the ground. So it only gives you speed over the ground. Which of these might not be seen on the radar? Wood, steel, GRP, fiberglass. Wood and fiberglass, GRP, glass reinforced plastic. Which would give rise to a potentially more dangerous situation? A log which overreads or a log which underreads? Have a think. Write your answer down. A log which underreads because you would arrive potential dangers faster than you expect, e.g. land, rocks, etc. What are the advantages of fitting radar to your boat? So the advantages of having radar on your boat: able to see in restricted visibility, can be used to fix your position, for collision avoidance, can be used in pilotage. You can see approaching rain and squalls, and the ability to see over the horizon. So it depends on how high the radar scanner is and how high the target is and the power of the radar you're using. We cover all this in the City Sailing RYA one-day radar course. What types of electronic charts gives you layers? Raster charts or vector charts? It'll be vector charts. So raster charts are just a scan of the chart. Vector charts, as you zoom in, like we do with our Navionics, will give us greater and greater detail. What do you need to consider when deciding where to put your waypoints? So you're doing a trip, you're popping your waypoints in. What would you consider when you put your waypoints in? Check the course over the ground between the waypoints. They don't cross a hazard or the land. Choose a position that can be checked by an alternative method. So it's next to a depth contour, it's on a transit, it's next to a buoy. So you can easily check that when you get to the waypoint, you're in the right place. Yay! Well done. We've done it. Wow, that only took us an hour and a bit, didn't it? Okay, doke. I hope you did really well. I hope you enjoyed it. Again, please like and subscribe to the channel. It took me quite a long time to put this one together. And thanks very much again for Chris Murdoch for putting the slides together. You're now ready to go to the mock exam. So go to the citysailing.com website. Go to the video section, go to Day Skipper, scroll down towards the bottom, and there's a couple of mock exams. You can download the PDF with the paper, print it off, do the exam, and go through the tutorial, and I'll explain the answers in detail for you. Thanks for choosing City Sailing. We'll see you again soon. Cheers. Bye. Out.